initialize and all that stuff. All right. Inequalities. Anybody tell me what an inequality is? Okay, good. That's one way to look at it. Something that's not equal, inequality. Somebody give me an example of an inequality. Now, I'll give you a hint. Inequalities are similar to equations, okay, but they're not equations. There's one specific difference, and it has to do with the word inequality. Anybody give me an example of one? Joshua. There you go. Way to look in the book, Joshua. See, Joshua has his book open so he can actually, see examples of what we're talking about. An inequality, okay, an inequality is similar to an equation, except it has an inequality sign instead of an equal sign. Okay? Now, where most equations have only one solution, inequalities most of the time have infinite solutions. Okay? Where we're used to seeing, with the exception of this last lesson, where we are used to seeing x equal 4, x equal -9, y equal 10, where there's one specific number that satisfies the equation. With inequalities, you're going to have x is greater than 10. Well, there's an infinite number of numbers greater than 10. 11, 12, 13, 14, 15, 16, 17, and on and on. Okay? So where an equation usually has one specific value, at least at this point in your mathematical careers, it has one specific value, inequalities have infinite. Now, they can make conditional inequalities where it'll say something to the extent of 5 is less than x is less than 12. Okay, well in that case that means x has to be something over 5 but less than 12. So there's not an infinite number of numbers, but there is still more than one solution to that. Okay, so let's remember our inequality signs. There's 4 of them. Okay, there's your 4 inequality signs. First one is less than. Okay, this one is less than or equal to. This one is greater than. This one is greater than or equal to. So those are your 4 inequality symbols, and that's how we say them. Okay, is less than, not less than. A while ago, Josh used the words less than. Well, less than means subtraction. Okay, is less than is this inequality sign. If I take off the is, you're no longer talking about an inequality sign. You're talking about a mathematical operation. Okay? Now, let me show you something. If I have this, x is less than 5. Okay? Well, what that means is this. If I draw a number line, and I have 0, 1, 2, 3, 4, 5, 6. Okay? I said x is less than 5. Well, that means this. I put a circle on the 5, and I draw an arrow pointing to the left, because left is less than. Okay? Now, if I said x is less than or equal to 5, well, then I draw me a number line. 0, 1, 2, 3, 4, 5, 6. And I do this. Now I color in my dot, and the arrow goes to the left. The reason that I color in the dot is because of that right there. If I don't have the less than or equal to, then I don't color in the dot. Like I did here. See, this dot is not colored in, this one is. Okay? Well, let's say I had, and I'm going to use the same letters and the same numbers, let's say I had x greater than 5. Well, then we draw our number line, and we go 0, 1, 2, 3, 4, 5, 6. Well, that means I have this. Circle, arrow to the right. That's how you would graph x greater than 5. X is less than or equal to 5. X is less than 5. That's how you would graph those three specific things. Your last one would be x is greater than or equal to 5. Okay, we draw our number line, 0, 1, 2, 3, 4, 5, 6. The only thing that changes, now I color in the dot, and I run it to the right. Okay, so that's how you would graph those solutions. And as you can tell, we've got a ton of numbers to the right of 5. Understand that I stopped at 6. I could have this, this could go out to 1 million. Okay, go out to trillion, zillion, gigamillions. Okay, it's infinite. There's an infinite number of numbers you could plug in to make that statement true. Okay, so that's how you would graph. This is the graph of inequality solutions. It's how you graph inequality solutions. Okay? Because the solving of the problem doesn't change. The solving part for addition and subtraction is exactly the same as it was for equations. Okay? That part of it doesn't change. The only thing that changes is where we were, most of the time I would let you put the answer's 5 and circle it, or the answer is 10 and circle it. Now you're going to have to put x, the less than or equal to sign, greater than or equal to sign, and then the number. Okay, you have to include the sign with your answer. If you don't, then obviously it would be wrong. So now let's look at some of the solving of inequalities. Solving of inequalities. For example, let's see here. M plus 8 is greater than 12. m plus 8 is greater than 12. Okay, once again, step 1, change all subtraction to addition. Change all subtraction to addition. Do I have any subtraction in this problem? No, I don't. Okay, step 2. Take the constant on the side of the variable to the other side of the inequality. And change the sign, change the side. Change the side, excuse me, did that backwards. Change the side, change the sign. Okay, so we're right back to where we were yesterday. Take this 8 over here. Here it is a positive, here it becomes a negative. So I have m greater than 12 plus negative 8. What is 12 plus negative 8? 4. So m is greater than 4. And that's your answer. The directions will tell you to plot or graph the solution. I'm not going to ask you to do that. Now, you will have to do it on a test, so you need to understand it, but I'm not going to make you draw a number line and graph every one of the answers. Okay? So step 3 was solve by following the rules for adding positives and negatives. All right, let's look at another example. Z minus 15 is greater than 72. Z minus 15 is greater than 72. So, change all subtraction to addition and do the opposite of the number behind it. So that changes it to Z plus negative 15 is greater than 72. Now, the number with the variable, we take it from one side to the other. Here it was a negative. Here it becomes a positive. And so that gives me Z is greater than 72 plus 15. And that means Z is greater than what? 87. Okay, so it's fairly simplistic. Obviously, they'll eventually get harder, but for the time being, let's see here. A minus 10.2 is greater than 5.3. So we do have subtraction in the problem. So I'm going to change it from subtraction to addition and do the opposite of positive 10, which is negative 10. Okay. Now I'm going to take the negative 10.2 over to the other side. Here it was a negative. Here it becomes a positive. So that gives me A greater than, since they're decimals, I'm going to go ahead and line them up like so. Okay. That gives me A is greater than what, Josh?
15.5.
Oh, okay. Thank you. I got 15.5. Okay. 15.5. That is correct. A is greater than 15.5. All right, everybody look at number 12. Look at number 12, section 4, chapter 3, number 12. Joshua, read number 12 to us.
The greatest weight that a forklift can raise is 2,500 pounds.
Okay, the greatest weight, so can it lift 2,501 pounds? No. So they want me to write an inequality that would tell me how much weight the forklift can lift. So what would be the inequality to let any Joe Blow that walks up and let him know how much weight that forklift needs to lift or not lift? What would I write? Gracie. Okay, give me the inequality. Give me the actual inequality, which what I'm talking about is something like that right there. Give me something like that that would tell me. No, care less what the letter is, not the weather. I care less what the weather is. Yeah. Right. X is less than or equal to 2,500. So in other words, we can go up to 2,500, but we can't go any further than that. So it has to be anything from 0 to 2,500 pounds that forklift can move. If you have more than that, it can't move it, or you may tip over while it's moving it. Okay? So that's how you would do that one. Let's see. Copeland, read number 13 to us. Speed limit is 55 miles per hour. Okay? So what would be the inequality for the speed limit is 55 miles per hour? In other words, when do you get in trouble? If you go over the speed limit. Okay? You break the law when you go over the speed limit, not when you go 5 miles an hour over the speed limit. You break the law when you do 56 miles per hour. Now, law enforcement people don't tend to pull you over, but they could. Okay? So how would I write an inequality for that expression? Joshua? Q? Just feel like Q's not getting used enough these days, so you decided to use it? And we do need to have pounds on the other one. So Q, you're okay, in other words, if you go 55 miles an hour or slower, you're okay. That's not always true because some freeways have a minimum posted speed where a policeman can pull you over if you're going too slow. Okay, they don't do that much anymore, but used to. They used to have minimum speed limits that you had to go as well. But since we have so much traffic, they obviously can't put a minimum speed limit on, like the freeway out here. If you put a minimum of 25 miles per hour, then any time during rush hour, they can go through and give 1,000 tickets because everybody's going 1 mile an hour. Okay, so obviously they can't do minimums anymore. Yeah, that would be bad. All right? So that's number 13. So you're getting the idea there. Now let's look at number 17. I want you to give me the inequality that number 17 represents. I want you to give me the inequality that number 17 represents. Now, before I do that, remember, If an arrow goes this way, that's greater than. If an arrow goes this way, that is less than. If the arrow points to the left, it's less than. The arrow points to the right, it's greater than. It's number 17. So tell me, what is the inequality for number 17? Nicole? No, you're close. Gracie? What's the letter? Yes. P is greater than -1. Okay? It's not equal to because the little circle's not colored in. If the circle's colored in like it is on number 18, then it is less than or equal to or greater than or equal to. It's only when the circle is colored in that you have to use the equal part too. Or you can just write the answer on those. Okay? So your homework. Homework is 3.4. through 40. Now, obviously, on 12 through 20, all you got to do is write answers. Okay? 21 through 40, you will obviously have to show your work, write the original problem, all that good stuff. Okay? We still have, about 15 minutes left in class. Let's go ahead and get started on it. That way, if you have questions, I can help you on any questions that you have.